All right, so we're doing day 2, section 4.2, the real zeros of a polynomial function. What we're looking at today is the theorem for bounds on zeros. So this theorem states that every polynomial function with real coefficients can be uniquely factored into a product of linear factors and or irreducible quadratic factors. And then the corollary says a polynomial function with real coefficients of odd degree has at least one real zero. So that means basically if it's a polynomial and it does not contain imaginary numbers, remember imaginary numbers are the i's, and if they don't have imaginary numbers, then it can be factored. So according to upper and lower bounds, so officially it says a number m is an upper bound to the zeros of a polynomial if f if no zero of f is greater than m. The number m is a lower bound if no zero of f is less than m. Accordingly, if m is a lower bound and m is an upper bound to the zeros of a polynomial function, then the little m is less than, or the lower bound is less than or equal to any zero of f, and which is less than the upper bound. So that is a bit confusing with the way it's worded. So a simple way of looking at it is on a number line, you have 0 in the middle, okay, and you have this upper bound. And basically, the upper bound is a positive number such that no solution, so remember a solution to a polynomial is a zero, no solution to a polynomial is bigger. So none of the solution zeros can be to the right of the upper bound. The lower bound is basically the opposite. It's a negative number or zero such that no solution to a polynomial is smaller. So this lower bound would be your little m, and the upper bound is your uppercase m. And basically, altogether, what this is saying is that all solutions are contained in an interval between the upper and lower bound. And what we use the upper and lower bound for is if we can find the upper and lower bound, we can use it to take our potential zeros that we found previously and we can minimize them, so that way we know we only have to look at these few numbers to see if it's a solution to the polynomial function. So in this theorem for the bounds on zeros, we're going to let f denote a polynomial function whose leading coefficient is positive if m is greater than 0, is a real number, and if the third row in the process of synthetic division of f by x minus m contains only numbers that are positive or 0, then m is an upper bound to the zeros of f. And it's a lot of words. We're going to look at an example that kind of makes this easier to understand. So if little m is less than 0 is a real number, and if the third row in the process of synthetic division by f by x minus m contains numbers that alternate positive or 0 and negative or 0, then m is a lower bound. And we are going to look at an example for this, okay? So basically, for the polynomial function f of x, 2x to the third plus 11x squared minus 7x minus 6, use the bounds on zeros theorem to find integer upper and lower bounds to the zeros of f. So first thing we have to do is we have to figure out what our potential rational zeros are. Okay, so remember the constant on your polynomial is your p-value. So we want to find our potential p-values of -6 in this case, and that is the factors of p. So that would be plus and minus 1, and we know that 1 times 6 is 6, so that's 2 factors. And we also know our other factors would be 2 times 3, so plus and minus 2, plus or minus 3. So we have 1, 2, 3, 4, positive and negative, so we have a total of 8 potential factors for 6. Now for our q value is the leading coefficient, which in this case is 2. So our factors for 2 are just simply plus and minus 1 and plus and minus 2. So now we need to find our potential zeros, which is p divided by q. And that is going to equal, let's see, 1 divided by 1 is 1, so it's plus or minus 1. 1 divided by 1 divided by 2 is 1/2, so that's plus or minus 1/2. Next number, 2 divided by 1 is 2, so that's plus or minus 2. 2 divided by 2 is 1, which we already have listed. 3 divided by 1 is plus or minus 3. And 3 divided by 2 is 3/2, so that would be plus and minus 3/2. 6 divided by 1 would give us plus or minus 6. And 6 divided by 2 is 3, which we already have listed. So these are our potential upper and lower these are our potential zeros for our for our polynomial function. Okay, so to look for the upper bound using synthetic division, that means our third row should all be positive. And you really want to start with the lowest positive number. So when looking for the upper bound, start with the lowest positive number. Or integer, I should say. Remember, integer is a whole number. That is a rational zero. Okay, so in this case, our lowest possible value would be positive 1. And that's an integer because it's a whole number. Because I know 1/3 is less than 1, but it's not a whole number. So we're going to take that 1 and we're going to do synthetic division. So we'll go ahead and set it up. So we're going to use our value 1. And then now we need to look back up at our equation up here. So we have 2x to the third, so 2 would be the first number. Now I need my x squared value, which is 11. My x value is -7, and then my constant would be -6. So now we want to do our synthetic division. Okay, so that means 2 gets dropped down. 1 times 2 is 2. 11 plus 2 is 13. 1 times 13 is 13. -7 plus 13 is 6. 1 times 6 is 6. -6 plus 6 is 0. So what we need to look at is this third row right here. Okay, and we said that the third row for the upper bound should all be positive. All of my integers here on the bottom are positive. So in this case, because the third row is all positive or 0, this is the upper bound. And what that tells us is that there are no zeros greater than 1. Okay, so this factor, this would be the factor x minus 1. Because remember, this is x equals 1. We would have to move the 1 to the other side by subtracting it, and that would leave us with x minus 1 equals 0. So that is one of our zeros. And that is the upper level. So knowing this, I know +2, +3, +3/2, and +6 are not going to be 0. So I don't need to test those with the synthetic division to see if I get a remainder of 0. Because I know with this being an upper bound that they are not potential zeros for my polynomial. Okay, so now we're going to look for the lower bounds, and I'm going to paste these are my potential zeros, or my potential real, rational zeros from the previous slide. So with the lower bound, we're using synthetic division. The third row should be alternate signs or 0. And when we're looking for the lower bound, we want to start with the largest negative value. So we need to start with the largest negative integer that is a rational 0. All right, so we know if you think about it on a number line, okay, our numbers appear to be going backwards. So as the number after the negative gets bigger, the negative number is actually getting smaller. So looking up here, our largest negative number is actually going to be -1. So we are going to want to start with -1 for our synthetic division. And don't forget, our numbers are going to be 2, 11, -7, -6. Okay, so moving this down. 2 goes down. -1 times 2 is -2. 11 minus 2 is 9. -1 times 9 is -9. Add -7 and -9, I get -16. +16, -6 plus 16 is 10. So if I look at this third row again, for it to be a lower bound, I need the third row to alternate signs. And I've got a positive, positive, negative, positive. So in this case, this one is not, I'm going to put LB for lower bound. So this is not a lower bound. So that means I need to go to the next number. And I'm going to go to the whole number, not the fraction. Okay, so our next number is -2. Set up our synthetic division. Okay, bring our 2 down. So 2 times -2 is -4. 11 and -4 is 7. -2 times 7 is -14. Add those two together and we get -21. Negative times a negative is a positive. And we get +42 and a remainder of 36. So same thing. Our signs are not alternating. We got 2 positives in a row, so this is not a lower bound. And sometimes you have to do this several times before you find the answer. So our next, we did -1, we did -2, so our next one is -3. 2, 11, -7, -6. All right, so let's bring down the 2. We get -6 plus 11 is 5. -15. Add it and we get -22. -66 and we get, not -66, +66, because a negative times a negative is a positive. So +66. Once again, they are not alternating, so this is not a lower bound. So we have to go on to the next one. Okay, so the next one, we had -3. The next whole number is -6. So we are going to use -6. 2, 11, -7, -6. Bring down the 2. 2 times -6 is -12. We get a -1. Negative times a negative is a +6. -1. Negative times a negative is a +6. 0. So this one, because our signs do not alternate, is not our lower bound. However, we do know that because the remainder is 0, this is one of our factors. Okay, so this is not a lower bound, but is a real 0. which our factor would be x plus 6 for this one. Okay, so now we ran out of numbers on here. We don't have any negative numbers smaller than -6. So when that happens, when you're looking for a bound, you just go down to the next negative number. So the next negative number below -6 is -7. 2, 11, -7, -6. And this should work out to be alternating signs. So we have 2 times -7 is -14. -3, -7 times -3 is a positive 21. We get a 14. -7 times 14 is -98. And that gives us a remainder of a -104. So if we look at our final row, our signs are alternating. So this means this is the lower bound. Okay, so there are no real solutions or no real zeros are lower than -7. Okay, so the answer to our question is our upper bound we said was 1, and our lower bound is -7. Okay, and you're not always going to have to go as long as we did on this, but on this one it just so happened that our one factor was way down at x plus 6, which is -6. Okay. All right, we're going to do the one more example. So for the polynomial function, f of x equals 2x to the 4th minus x to the 3rd plus 2x squared minus 12. We want to use the bounds of zeros theorem to find the integer upper and lower bounds of 0. So once again, we want to find our p and our q values. So our p would be starting at -12. So our factors for -12 would be plus or minus 1, plus or minus 2, oops, wrote that wrong, plus or minus 2, plus or minus 3. So I know that would be 3 times 4. So plus or minus 4, plus or minus 2 times 6. And then our last one would be plus or minus 12. Our q would be the 2. So our factors of 2 are plus or minus 1 and plus or minus 2. Remember, the p goes on the top and the q goes on the bottom. So 1 divided by 1 is 1, so that's plus or minus 1. 1 divided by 2 is plus or minus 1/2. 2 divided by 1 is plus or minus 2. 2 divided by 2 is 1, which is already listed. 3 divided by 1 is 3. 3 divided by 2 would be plus or minus 3/2. 4 divided by 1 is plus 1. 4 divided by 2 is 2, which is already listed, so we don't need to list it again. 6 divided by 1 is 6, plus or minus 6. 6 divided by 2 is 3, which is already listed. And then plus or minus 12, and 12 divided by 2 is 6, which is already listed. So these are all our potential zeros. So we want to look for the upper bound. Just as a reminder, we're looking for all positive in the third row. And we want to start with our lowest number that's positive, which is in an integer, which is 1. Okay, so 2x to the fourth is 2. So we need the x to the third number, which is -1. X squared number coefficient is 2. We don't have an x coefficient. So that means we need to put 0 because there are 0 x's. Okay, so we have 2x to the fourth, we have a -1x to the third, we have 2x squared, but we have 0 x's. And then our last number would be -12. So don't forget when you're doing synthetic division to put in that placeholder when a variable is missing there, okay? So let's go ahead and do this division. So bring down the 2. 1 times 2 is 2. -1 plus 2 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. -12 plus 3 is -9. So we have all positive and a negative. So this one is not an upper bound. Okay, so we'll have to do this another time. So our next number, that's a whole number, is 2. Because we're using the same equation, we can just copy our first row for our synthetic division. Okay, 2 times 2 is 4. 3. 2 times 3 is 6. 8. 2 times 8 is 16. Add, we get 16. 2 times 16 is 32. -12 plus 32 is 20. This is all positive. So therefore, our upper bound is 2. So you can see why, if we're looking for the zeros of an equation, we've just cut off 1, 2, 3. Wait, 1, 2, 3. Why did I list -1 twice? Oh, this is supposed to be a 4. That's what that is. Okay. So we can see we've cut off 1, 2, 3, 4, 5 numbers that we don't have to look at for zeros, because we know our upper bound is 2, and if we're looking for zeros, we don't need to look at those 5 numbers now. Okay? So let's look at the lower bound. So our lower bound, remember, we need to have alternating signs. Okay, and our highest negative number is going to be -1. So we have -1. Our synthetic division has the same first row values because they're all for the same polynomial. All right, bring down our 2, -2. Add them together, we get a -3. Negative times a negative is a +3. 5. -1 times 5 is -5. -5. Negative times a negative is a +5. And we end up with a -7. So this one we can say is not a lower bound, because you have two negatives side by side. Okay, does that make sense? We have these two negatives right here side by side, so it cannot be a lower bound. So let's go back up. We had -1, so now we want to go look at what's our next lowest negative number, which would be -2. So let's do our synthetic division for -2. 2, -1, 2, 0, -12. Okay, bring down our 2. -2 times a +2 is -4. And that would give us -5. Negative times negative is a positive, so we have a +10. Add them together and we get 12. -2 times 12 is -24. We get a total of -24, and a negative times a negative is a positive. We get a +48, and we're left with a +36. So in this case, the signs are alternating. So that means our lower bound is -2. Okay, so now if we're trying to find the zeros for this function, for this polynomial function, if you think about it, if we were trying to find the zeros, all right, we said the upper bound is 2, and anything above it we won't have to look at. Our lower bound is -2. We don't have to look at anything below it. So that means our potential numbers would be -1, +1. Our other potential number would be -0.5, +0.5. 2 could be a potential, -2 could be a potential. Everything else listed on here is outside of our bounds. So we wouldn't even use these, or actually, I'm sorry, 3.5 would actually. 3 wouldn't work, 4, 6, and 12 wouldn't work, but 3.5 is really 1.5, so we would have to look at 3/2 and -3/2 as potential solutions too. But look at how much that cuts that down. That's 2, 4, 6, 8 numbers that we wouldn't have to search for the zero on.